Hi guys, welcome back to the video series on blockchain oracles. So in this one, we'll talk about another oracle that is gaining a lot of traction these days. But before that, if you have been following along, let's do a quick recap. So far we have talked about what oracles are, why do they exist, what are some of the use cases of them. Then we also covered what are the different categories of oracle, and we have done two hands-on demo using Chainlink. One of them was for getting the price feed data on Ethereum using Chainlink, and the other one was for generating random numbers on Ethereum using VRF in Chainlink. So that's what we have done so far. And in this one, we'll talk about Pyth, which is another blockchain oracle protocol. So let's get started. In case you have missed out my previous videos, do check them out. I'll share the playlist link in the description. So now let's take a moment to see why I want to talk about Python in general. So if you see here, this is DeFi Llama, the website that I told you about in the first episode. So if you see here, as we have seen already, Chainlink is like the leading provider. Other than that, if you see, Pyth is among the top five blockchain oracles, and see the number of protocols it is supporting, which is like second most in the whole list. And one interesting thing to note about Pyth is the volume. So if you see this column, volume in last 30 days. So for Chainlink, the volume is $32 billion, and for Pyth, this is $36 billion. What it means is Pyth is gaining a lot of popularity these days, as you can easily see from the volume figure that we have shown here. So let's go to the Pyth website. It says blockchain oracle for market data. So their focus is majorly on the DeFi space. They are providing reliable, low latency market data. And if you see here on the right, they provide data not just for the crypto, but also for equities, forex, and commodities. And let's scroll down below. So they are providing real-time market data anytime, anywhere. And they have also linked a white paper here, which is pretty interesting in case you want to deep dive into it. So do check it out. And the number of blockchains it supports is 80 plus, and it is having 430 plus apps so far, which are either a DEX, a lending protocol, or some derivatives platform. And then it supports 540 plus data feeds to meet the reliability standards of DeFi space. How they work is they have this concept of getting the first party data. So, all these financial institutions that we know, like some of the world's biggest exchanges like Binance and OKX and market makers and some of the major trading firms, they provide the data directly to the Pyth network. So the data that we are fetching using Pyth is the data that we can trust because it's coming from the first party itself. One unique thing to note here is it's a pull based oracle. What it means is you get the data on demand. So basically, you will pay only for what you want, and that ensures that the updates are being delivered to you. And here they have given a short video of how the synthetic perps are being made competitive on using Pyth. The reason being Pyth updates the price feed every 400 milliseconds, which is such a low latency that we have. And they have different options for integrating on different chains. So either you can integrate it directly into a smart contracts, or let's say even if you're front end, then also they provide certain means to integrate it. And that we'll see the integration for smart contract in a while. So that's pretty much the overview of Pyth network that I wanted to give. So now let's see what they have in store for developers. So we'll go to the documentation. If you see here, Pyth Network provides different products for developers. The first one being the price feeds, providing real-time price data for 500 plus assets, and it supports many EVM chains, Solana, Aptos, Sui, Near, and several Cosmos chains. Then the second product that it provides is the benchmarks, which is basically to provide historical prices data for both on-chain and off-chain use cases. Then they provide something called Express Relay, which enables protocols to eliminate their MEV while gaining access to active searchers and liquidators. Don't worry if it doesn't make sense because MEV in itself is a pretty complex topic. We'll talk about in some other video series. Then the last product that they have is entropy, which is what allows you to generate secure random numbers on the blockchain. So these are the four products that they provide. So in this video, we'll do the hands-on demo for the price feed. Okay, so let's go to the getting started guide. And here they have said integrating Pyth price is really quick and easy. And the price feeds that Pyth provides are available on chain and are permissionless. So we don't have to really need to sign up anywhere or we don't need a API key. And the build section is what the developer should use, and then they also have a learn section. So if you see here, the build section is basically for creating your first Pyth app, and the learn section is for somebody who wants to deep dive about Pyth in more details, like if you want to understand the Pyth architecture and how Pyth works. So we'll go to this create your first app and then we'll select the environment as EVM. For the demo, we'll create a smart contract that reads the price from Pyth and the price that will fetch would be the price of ETH in USD. And for this tutorial, we'll need Foundry to perform the smart contract task. So before moving ahead, ensure that you have Foundry installed. So let's jump into the demo. This is the code that I've written for demo. Don't worry if you want to follow along. I'll link the GitHub repo in the description. So first, let me walk you guys through the code. This is the Solidity smart contract that you see over here. The contract is named price feed. And if you see here, we have an import. But you might be wondering the import doesn't look like this. So you are right. Actually, this is like a shortcut or an alias that we have created. So we have this file called remappings.txt, which create an alias for the node modules for Pyth Network, for Pyth SDK Solidity. So basically, the Pyth provides the Solidity SDK to get the real price feed data. And in this case, there are certain prerequisites for you to run the demo. First being you need to have Node installed on your machine. Second, you need to have Foundry installed. So Foundry is like a smart contract development toolchain. And once you install Foundry, there will be pre-built binaries installed in it, such as Forge and Cast, which is something that we'll use in this demo. So how you can check that is open a terminal and then type node -v. You'll get the node version if it's already installed. Do the same thing for Forge. So here you got the help menu for the Forge. So Forge is one of the tools of Foundry like we just talked about. So Forge helps you in building, testing, deploying and debugging your smart contracts. We'll use Forge to build and deploy the smart contract on Ethereum, Sepolia, testnet. So Cast basically allows you to perform Ethereum RPC calls and it's also like a CLI tool. So that's the prerequisite part. The Pyth provides us some Solidity SDK to interact. So there's this interface called iPyth, which is something that we'll use for our interaction. So if you see here, inside the contract, we have a state variable for the interface. We have a variable for storing the price ID as well. And then there's a constructor where we are initializing the Pyth contract address and also the ETH price ID. And if you're not very sure from where you will get these, so hold on, I'll take you the Pyth website to let you know how you can fetch these values. So we have three functions here. The first one is for getting the current ETH USD price. And if you see, we are using the same Pyth interface, and this is the method that we are using, get price no older than. Okay, so I'll quickly take you guys into the IPyth interface. And here, if you see, there are certain functions. So this one that we are using called get no price older than, it returns the price which is not older than the age, which is in seconds that you have passed. So in our case, we are using the age as 5 minutes, which is 300 seconds, just for the purpose of demo, but you can play around with this. And then we cast it into the type of into 56, which in turns is cast into u into 56. So if you see this get price no older than function, it returns the price which is from this structure. So let's see what is this. So there's another contract for storing the Pyth structure, and this is the price structure. So we're just interested in fetching the price, that they also have something, but there's something called confidence score, price exponent, and the publish timestamp. So this is how the get function looks like. Then there's an important thing to note. As we already discussed, it's a pull-based oracle, right? So if you call the get price directly, you will get an error for stale data. So what we need to do is we need to update the price feed before calling it. And this is a function for it. So updating price feed means giving a call to the Pyth contract for updation, which requires gas fees and which is something which the user will pay. So if you see here, we are calling this get update fee, which is returning us the fees required to update the price feed. And once we have the fees, then we are actually calling this update price feeds function of the Pyth interface along with a certain value, which is the value of each that we are passing, and this variable that you see as input to this update price is the bytes array, and this is something that we'll get from the Hermes API. So Hermes is like a off-chain service that the Pyth guys have provided to let you know about the latest price update data, and you can directly use those Hermes API to get the details, and this is what will pass in input to this function. And here if you see the last function, which is to update and get the price as well. So basically this is just a combination of the other two functions that we have seen above. So this is how the smart contract looks like. I hope this was useful. Now let me show you how can you get these two information for initializing the constructor. So we'll go to the Pyth website, and here this is the home page. We'll go to the price feed section, and then we'll scroll down to the reference material section. Here you see contract addresses. We'll click on EVM, and here we'll search for Ethereum Sepolia. So this is the contract address for Sepolia, which is the Ethereum testnet. So we'll copy it, and this becomes the first argument of the constructor. Then we had a second argument for the constructor called the price feed. So for that, we'll scroll over here. It says price feed IDs available here. And here we'll directly search for ETH slash USD, and this is the price feed ID that we're interested in. We'll copy it and use it in the constructor of the contract. In case you are planning to do a hands-on demo along with me, in this repository that we have, I've created a README file where I've listed all the instructions that are necessary to build, deploy the contract, and how we'll interact with the smart contract via Cast CLI. So you just have to fork this repo and then come to the README, and you will get all the commands that I'm using in this demo. So let's switch to the demo part. Okay, so you open the repository in your favorite ID and ensure that you have all the prerequisites installed that we talked about. We'll follow the instructions that are there in the README. So first we'll build a project, we'll use the forge build command. So in my case, since no files have changed and I've already compiled it, the compilation has skipped. But in your case, if you're doing it for the first time, you will see the message saying the compilation is successful. Then we'll deploy the smart contract. So we need all these environment variables. I've already exported my private key. You can get the private key from the account that you are using. Like it could be any wallet of your choice. So we'll export the rest of the three variables. And these two variables that you see here are the ones that we got from the Pyth website. And this is the RPC URL for Sapolia test network. Now we'll go ahead and deploy the smart contract by using the forge create command. So if you see here, as part of deployment also first the compilation is going on and the compilation has been skipped. So this might take some time to get the deployment done. So let's stick on. And once the deployment is done, we'll get the deployment address. We need to copy that address as this variable and export it. So if you see here, I got these details. This is the address that we are interested in. I'll copy it and paste it over here. This is the address at which my smart contract is deployed. I'll export this variable called deployment address. Now, let's try to interact with the smart contract. So we already know the functions that exist in the smart contract. We'll call this function called get ETH USD price. Turns the real-time price of ETH in USD. So let's copy it. And I'm running it with trace flag to get more detailed logging. So I wanted to show you guys something, that's why I'm running this here. So if you see here the transaction has failed and then we see a custom error. To understand this, we have to switch back to the Pyth website. So let's go to it. If you see here, we have to go to the point where the error codes are mentioned in the reference material for ethereum. I'll search for the error code that I got, and this corresponds to the error for stale price. What it means is the requested price field has not been updated recently enough. And this is what happens when you're using a pull based oracle and the price is stale, it will just throw you an error instead of returning a price that it's stale. So that error handling has already been done for you, right? So now what we need to do is we need to actually update the price feed. So let's switch to the Visual Studio Code. Okay, so for this we'll use Hermes API and I'll talk a little bit about Hermes API at the end. So for now, let's copy this curl command and we'll run it. So basically we are calling a Hermes endpoint for getting the latest price for our ETH USD pair and we are storing it in this price update.txt file. This is how it looks like. Then once we have it stored in this file, what we can do is we'll actually call the get and update method. So I'll copy this command. We'll run it here. Okay, so since it's asking for a private key because I have this interactive mode on, I'll cancel it. I'll run it again. And for sending a transaction that will update the state of the blockchain, we have to use cast along with the send command. And since this function was payable, we are passing some ether to it. So let's wait for some time. Once this is done, we'll call the get function again. Okay, so now if you see here, these are the details that we got. We got the transaction hash and then the status is success. So it means it all went through successfully. Now let's again check the get call. If you see here, we got a very big random number, right? And you're not able to make sense of it. This is because this number is in hexadecimal. So let's use cast command only to convert this number to decimal. We'll copy the result here. And this is what we got. And if you want to verify if this is true or not, let's do a Google search and see what is the price of ETH today in USD. So if you see here, the ETH price in USD is $3,052.27. And I'll go back to the response that we got. If you see, this is $3,035. And why I'm reading it like that is because in case of Pyth, we saw price structure was having an exponent field, right? So in this case, the exponent is set to -8. So it means there are like 8 decimals in it, which makes it $3,035.89, which is almost close to the real price. So that's about the demo. And now I'll talk a little bit about what is Hermes API. If we go to how to guides and we go to fetch price updates, so we see here that the price updates are being served from Hermes, which provide you different ways to fetch price updates. And in our case, we were using REST API, but you're free to explore with the SDK that they have, and also they have a streaming option. So we use something like this. We used a get call for getting the latest price, depending on the price ID that we passed in. So this is how the response looks like. And for Hermes, it's like a web service that the Pyth team has provided that listens to the PythNet and the wormhole network for Pyth price updates and just serves us in a very convenient way. So it allows user to query for recent price updates, and you could use the streaming updates using a WebSocket, or you can use the JavaScript SDKs as well. So if you want to read about it in more depth, you can check out the documentation that they have here. This brings us to the end of the fifth episode related to Pi. And in case you haven't checked my earlier episodes, do check them out. We have done a couple of detailed hands-on demo related to Chainlink. And if you want me to cover any other topic in Web3 space, do let me know. And please show some love in case you find this helpful. Share, like, and subscribe to the channel and spread the word. It will mean a lot to me. Thank you so much for watching. I'll see you in the next one. Bye bye.